Hello and welcome to Guardian. This will be part 4 where we actually set up a battery and run the program. This is one of the fixtures that I use. It will hold pretty high current and it also air gaps the battery, so I can easily set up a fan. I usually start with the thermocouples. I'll tape them onto the side of the battery. You got to make sure you identify the positive side of the battery and make sure it is in the positive side of the fixture. The battery analyzer does have a reverse polarity detector, so it will not run as long as the battery is either not hooked up or hooked up backwards, which is a nice safety feature. So you got to hook up your voltage probes. That's what detects voltage at the local point rather than at the source or the load. You get a much more accurate reading that way. Alright, so we're back into our program. Just make sure we save it. And it's already loaded. We're going to give it a name. Generic name, we'll use Guardian. And test, something simple. And all that's left is to press run program. So after you press run program, it goes through a fairly lengthy connecting to hardware phase. And what it's actually doing is it is connecting to hardware. It's connecting to the data queue, both the load and the power supply. But it's also instilling and checking all of its safety gates. There's a tremendous amount of safety features built into the system so that if a voltage probe comes off, if voltage goes too high, goes too low, same with current, if it goes too high or goes too low. Anything out of what is expected, it will just shut the system off out of safety. Some of the things we have going on here, you can look at the top, we have our session timer running, adding time up as we go along. We are currently charging at about positive half an amp and voltage at 4.1. So we're already in a constant voltage charge state, I believe. This battery must have been already full. I'm going to go ahead and let this run for a little while, and we will come back and see how it's been performing. Okay, after about 2.5 hours of runtime, we can see that some things have changed on the graph. So right here is where phase 1 officially started, marked by the P1 marker. And we can kind of scroll forward on the graph and see where P2, or phase 2, started. You can see over here in the phase panel, phase 2 is what phase is actually running right now, and the P2 in status is counting our amp hours. And see where P2 started. The graph allows us to kind of move around and zoom in and out as we please during the live run. The slider 1 right there is a marker I put in when I opened a window. And you can see as soon as I opened the window, my temperatures dropped and became rather unstable. Not really important for the test, but just an interesting note. Let's go ahead and let it finish the run, and we'll come back and do the analysis at the end of run. Alright, we've returned to a successfully completed run. Some of these numbers up here are pretty good. P2 measured 3.3 amp hours, 12 watt hours. The battery was rated at 2950 milliamp hours, so that gives us a state of health of 115%. That's really good for a used battery. The last thing we can do here at the end of the run is save all of the run data, and you just click yes if you want to save it, and it will ask for a save location, which this is fine. This is the run that we just completed. You can save it on a network accessible storage or anywhere else. They can tend to be pretty large files when you get into these 7 or 10 hour runs. This is going to conclude our introduction series. Please follow us if you'd like to learn more and watch us develop this software and tool as we go along. Thank you and goodbye.